All right, so we're going to pick up where we left off yesterday with section 6.1. We had just gone through all 6 trig functions for the point 0, 1. Let's try going through the 6 trig functions for this one, 1/2 root 3 over 2. Now, does that look like the coordinate for either 0, 90, 180, or 270? No, it's not. It's another coordinate on the unit circle, which we haven't learned yet. We don't have to know what angle is represented by that coordinate. Okay. Not important. What's important is the location. Okay. And we have an x and a y. So that coordinate represents the location of some angle on the circle. And we're going to find the sine, the cosine. We're going to do all 6 for whatever angle is represented by that coordinate. Okay. Let's start with the sine. What is the definition of sine? Y. And in this case, my y value is? Square root of 3 over 2. So whatever angle that coordinate represents, that angle has a sine of root 3 over 2. Let's do the cosine. What's the definition for cosine? X. And in this case, x is 1/2. And tangent? What's the formula for tangent? Y over x. Well, we have y and x right above it. So imagine just putting like a division line right there and dividing those two numbers. We're dividing things and they have the same denominator. What happens to the denominator when you divide 2 fractions and the denominators are the same? They cancel out. So the 2's are going to cancel. You're left with a root 3 in the top, and you're left with a 1 in the bottom. So you're just left with root 3 over 1 or root 3. Okay. Now, once we get the 3 that are on the left, what do we do with each one of them to get the 3 on the right?
Flip them.
Flip them. So you can flip that. You get 2 over the square root of 3, but you cannot leave it like that. What's wrong with that? Right, we can't leave the square root in the bottom. So what would you multiply by to fix it? The square root of 3 over 2. Well, what's the only thing you can multiply by and it doesn't change a number? 1. Okay, so you have to multiply by 1 here. So what would have to go in the denominator? No. If you put 1 in the denominator, you're not
Root 3.
root 3. Yeah. So you're going to multiply by root 3 over root 3. What do you get when you do that? 2 times root 3 over?
Root 3 squared.
Okay, root 3 squared, which is 3. Yeah. So 2 root 3 over 3. What's the name of the next trig function below cosecant? Secant. And which function do you flip to get the secant? Cosine. And what do we get if you flip the cosine? 2. All right. And the last trig function? Cotangent. Which function do you flip to get that?
The tangent.
The tangent. If you want to think of the tangent as a fraction, just pretend it's over 1. What would you get when you flip the tangent?
Square root of 3.
Okay, we could start with that, but then when we fix it,
It would be 1 square root 3 over 3.
square root 3 over 3. Yep. So those are the 6 trig functions for some angle represented by that location. If you really want to know what the angle is, it's 60 degrees. That is the coordinate for 60 degrees. But we're going to get to that. Okay, let's try this one. Find the 6 trig functions of 90 degrees. What's different about that question compared to example 1A and 1B? It doesn't have a coordinate. Okay, 90 degrees is not what's going to help you do unit circle trig. It's the location of 90 degrees. What is the location of 90 degrees?
0, 1.
Right, and that, we just have to memorize it. Okay, 0, 1. Now, I think we did this one in the homework. What's the sine of 90? 1. Cosine?
0.
0. Tangent? Undefined. Cosecant? 1. Secant? Undefined. And cotangent? 0. Yep. So the only difference between this problem and the last problem is the last problem, all you had was a location and you didn't know the angle. This time, they gave you the angle, but you had to figure out the location and then do the problem. Let's try this one. 6 trig functions of 270. What is it that we need to find first? Gotta get the coordinate. Yep. If you can't figure out the coordinate, then you can't do unit circle trig. Okay. What is the coordinate for 270? 0, -1. And now, let's go through all 6. Start with the sign.
-1.
-1. The cosine of 270 degrees?
0.
0. Tangent?
-1 is undefined.
Undefined, yep. Always simplify that as much as you can. So that's undefined. Cosecant of 270. -2, yeah, cosecant of 270. Yep. -1. How about the secant of 270? Undefined. And the cotangent of 270? 0. Yep. Any questions on that one? Right. Anybody, I think, did we do that one? We did pi in the homework, right? So we already did that one. Okay. Let's try this one. 6 trig functions of 7 pi over 2. What is it that we ultimately have to figure out to do this unit circle trig?
The coordinate.
You have to find the coordinate. What would make finding the coordinate a little easier on this one?
Converting it to a degree.
Yeah, we could change it to degrees. And if you remember this, break it down a little bit. What is pi divided by 2? That's 90 times 7. What's 90 times 7?
560.
Yeah? No.
600.
What's 9 times 7 and then add a 0?
530.
No.
630.
630. 9 times 7? 63.
I know I can do
Okay. So that's 90 times 7, which is 630. But that's still kind of a big angle to work with. What could we do with that angle to make it smaller, but it would still be equivalent when we do this problem out? Yeah.
Subtract 360.
Right. We could just subtract 360 from that. So take 630 minus 360, and now you get 270. So, did we do 270 again? Yeah, we already did it. So, example 3 is exactly the same as example 5. So, see example 3 for all the answers there. How about negative 90? What is it that you don't think I like about that one? I don't like that it's a negative angle, so how could I make it positive?
Add 360.
Add 360. And what do you get if you add 360 to that?
270.
You get 270, which is the same question again. Okay. So it's example 3, 5, and 6. They look like different questions. They're not. They're all the same question. See example 3. Any questions on that? Yeah.
For example 5, where the cost of this, I'm just curious, I put that in the calculator and that's not,
Yeah, we're not going to use a calculator for those ones.
oh, we're not.
Yeah, we're going to do it using the definition by getting a coordinate on the unit circle.
Oh,
Yeah. We are going to do some with a calculator in a few minutes. Well, in a little bit. Yeah. Okay, so let's take a look at the last part of unit circle trig. So we've talked about finding the coordinates of quadrantal angles. Now we're going to look at how do you find the coordinates of angles that are 30s, 60s, and 45s, or multiples. So angles that are multiples would be like 120, 150, 210. Right? Multiples of 45, 45, 35, 225, 315. Those are the numbers we're going to see come up quite a bit. So looking at these three angles, what's pi over 6 in degrees? $30. What's pi over 3? 60. And pi over 4? 45. Yep. Okay, so we're gonna start with a 45. Okay, we'll start with that angle, and the goal is going to be to figure out the coordinate for that angle. Once we figure it out, we don't ever want to have to figure it out again. Okay, so we're going to figure it out one time. Then we just want to always remember going forward what it is. Okay, so there is about how you would draw a 45-degree angle. We have to figure out, starting at the origin, how far to the right do you go? So we got to figure out how far right. And then we have to figure out how far up. How far to the right that we go is going to be which value in the coordinate? X. Yeah, that's the x. And how far up is the y. Yep. So basically, we're going to be looking at working with what shape in that picture? A right triangle. So the goal is to figure out the base and the height of the right triangle, and that is my x and my y. All right, so now that's my 90. That's a 45, because that's the hypotenuse is tilted at a 45-degree angle. What's the angle at the top?
5.
Why is that one also 45?
Because the right triangle has a 90-degree angle. So overall it's 180 degrees.
Right. They all have to add up to 180. So that means the one at the top has to be a 45 because you already used up 45 and 90 at the bottom. So that is a 45, 45, 90 right triangle. I've drawn the same triangle a little bit bigger so we can just work with it a little easier. Is there any side in that triangle that we already know? Look at it up in that picture. Yep.
The hypotenuse,
Mm-hmm. How long is the hypotenuse?
the radius.
Which is? 1. Because everything here is about a unit circle. So we know that the hypotenuse of that is the radius, and that is 1. Now, is the 1 directly the x or the y coordinate? Is it one of those directly? What do you think? No, the 1 isn't the x or the y. But we can use it to get the x and the y. Besides being a right triangle, what other kind of triangle is that? It's isosceles. What does that mean? That it's isosceles.
That two angles are the same.
What else does it mean?
Two sides are the same length.
Two sides are the same, yeah. So if we have two sides that are the same, how does the base of that triangle compare to the height of it? They're gonna be the same. So we don't know what they are right now. So we got to pick a variable to represent it. But whatever variable you pick, use it twice. Okay? Don't use two different letters for the base and the height. If you do that, you're saying that they're different, but they're not different. So let's just pick a letter to use for the base and the height. Let's just use A. And now we have to set up a formula and solve for A. And whatever we get for that, that's going to be the x value and the y value of the coordinate. What theorem could I use that would set up a formula involving the A, and the 1? Yeah, here we go.
It's the a squared plus b squared equals c squared, but
What's that?
That's the right triangle.
The Pythagorean theorem. Can you explain to me how to plug into that theorem with my values that are on the board?
So you would do a squared, or well, plus, wouldn't it be another a squared equals 1 squared?
1 squared. So combine like terms. 2a squared equals 1. And now get a by itself. What would be our next step to get a alone?
Divide by 2.
Divide by 2. And my last step. Take the square root. And when you take a square root of a fraction, how do you do that? So taking a square root isn't the same as taking half of a number. Like for some numbers it might be like the square root of 4 is 2. That's just a coincidence. The square root of 9 is not half of 9. How do we take the square root of a fraction?
You just stick it.
How? Like what do I do? Like what's like? How do I do that? Yeah. S- Well, something times something would give you a half, but let's pretend like if you're taking the square root of 4, it would be 2. But we're taking the square root of a half. So we need to know, how do we write that down? Because I need some arithmetic I can do on paper.
Square root of 1 over 2.
The square root of 1 over, no, square root of 2.
Oh.
So when you square root a fraction, you just do each number in the fraction. Now simplify. What's the square root of 1?
1.
1. And now the only problem with that is we can't leave the square root in the bottom. So if we fix it, what would you get? Square root of 2 over 2. And that is what a is. A is the square root of 2 over 2. So now we know that's square root of 2 over 2. That is square root of 2 over 2. What would be the coordinate for 45 degrees? Square root of 2 over 2, comma, square root of 2 over 2. So that is always the coordinate for 45 degrees. Never changes. But if you had a 45-degree angle over here, that is 135 halfway between 90 and 180. What do you think the coordinate would be for 135? Two over two. Now, if you had a 45 down here, that's your 215. No, I'm sorry, 225. It's 225. That's halfway between. Oops. Halfway between 180 and 270. And what do you think the coordinate for 225 would be?
Negative square root 2 over 2 negative square root 2 over 2.
And the last 45 you can have is in quadrant 4. What's the 45-degree angle in quadrant 4?
Negative square root 2 over 2 negative square root 2 over 2.
So, well, what's the angle first?
Oh.
315. And what's the coordinate?
It would be square root 2 over 2 negative square root 2 over
Yep.
2.
So once you know your angle, and you know it's a 45, it's always going to have a root 2 over 2, comma root 2 over 2. The only difference is maybe it's positives, maybe they're negatives, depending on the quadrant. So that's how you deal with the 45s. Any questions on how we got the root 2 over 2? Not something we want to have to go back through and use Pythagorean theorem again. Okay, so that's the 45, 45. Okay, the 30, 60, 90. Let's look at that one. Let's look at the 30 first. Okay, so there's 30 degrees. That's 0. That's 90. So 30 is less than halfway. It's closer to the x-axis. If we make a triangle out of that, in our triangle, what is this angle right there?
30.
That's the 30. And what is this angle right there?
60.
60. So the numbers in blue are marking the angles on the inside of the triangle. The one in black is marking the rotation on the circle. Okay? That's the difference. So I've drawn the 30, 60, 90 off to the side bigger, so we can work with it. Is there any side in that triangle we already know?
Yes.
Yeah, what side?
The
Yeah. What's the hypotenuse?
1.
1. It's still the radius of the circle. Now, what kind of triangle is that, besides being a right triangle? It's scalene. What does that mean?
They're all different.
All the sides are different, all the angles are different. So the problem with trying to do this exactly the way we did the last one is if you want to label the two sides you don't know, you'd have to use different letters. And now when you plug into the Pythagorean theorem, how many variables would you be trying to solve for?
2.
That's not going to work. Okay, you can't solve for two variables at the same time. So we have to figure out one of these other sides first, somehow, a different way. Then we can use Pythagorean theorem. And my hint to doing it a different way is that. That's my hint. Anybody have an idea of what we could do?
Multiply by 2.
What's that?
Multiply by 2.
Well, it's something visual. Something, we're going to do something with what's on the board now.
I think that's adjacent.
Okay, what do you mean? What do you want to do with these two triangles?
Like back to back.
Which way?
Square, make a rectangle.
Make a rectangle?
Yeah.
Okay, so we could flip it to make a rectangle. You'd have to flip this one twice. So yep, that's it's definitely a rectangle now. I don't know what to do with that though. But we did make a rectangle. So
Yay.
that's good. Any other thoughts? What we could do?
I have it, it's just not.
Reflect it over
Reflected over
the y-axis.
the y-axis, so that's an up-down reflection? Okay.
No.
The x-axis.
No, I would do the y-axis. I would do it like that.
And then put that one on the bottom of it.
Like that?
No.
Oh,
Mr. Hager, you know what I'm telling you.
Oh.
Just do it.
like that?
Yes.
Okay. So now,
Now
an
we have to
airplane.
find that bottom length.
what do we have now?
A bird.
Oh.
Oh, an equilateral triangle.
It's an equilateral. That's 60, 60, 60.
Yeah. We did it.
So,
Good job, Shelby.
well, kind of, we're almost there. So now what do we know about an equilateral?
That all the sides are equal.
All the sides are equal. So this side is 1, that side's 1,
Oh.
and more importantly,
So the bottom.
that side is
So
1.
the height is 1/2.
So
Right.
it's 1/2 at the bottom.
Because these two sides are congruent. We know that because they're mirror images. So if you're adding two things that are identical and they're going to add up to 1, that means each one of them
Is one.
has to be a half.
Okay, now we can do the.
Now we can do the Pythagorean theorem. And we don't need the bottom triangle anymore. We can get rid of that. Okay. So that's a trick how we can figure out that side is a half. Now the bottom side we don't know, we'll just call it A. And now solve for A. But you already know one of the numbers in the coordinate for 30. The 1/2 is going to be the what?
Y.
That's the y. That's how far up you need to go from the axis to the point. So that's the y. Now we need the x. Okay, how could I set up Pythagorean theorem with those three values?
A squared
Well, we'll do a squared, but yeah.
plus 1/2 squared plus a squared.
Okay, so a squared. What's 1/2 squared? Oops. 1/4. Okay, so we get a squared plus a fourth equals 1. What does that mean? A squared would equal
3/4.
3/4. And what do we have to do on each side to get a alone?
Square root.
Take the square root. And how do we take the square root of 3/4?
Do the top and the bottom.
Square root of the top and the bottom. Can we simplify the square root of 3?
No.
No. Can we simplify the square root of 4? Yeah. What is that?
2.
2. There we go. So the length of the bottom side is square root 3 over 2. All right. So now we know that. What part of the coordinate is the root 3 over 2?
X.
That's the x. So that is always the coordinate for 30 degrees. That would also allow you to do 3 more other angles. It would allow you to do this one, and that one. It lets you do all the ones that are closer to the x. Comes out better if you use a ruler, but that's okay. What would this angle be over here?
Negative square root of
Just the angle, not the location. That's your 150. How about this angle right here?
Go to 10.
210. And this angle over here.
$330.
330. Right. And we should be able to get the coordinates of all those because they're just reflections of the original. what would be the coordinate for 330?
Square root of 3 over 2,
Yep. And for 210?
negative square root of 3 over 2,
Half. And for 150?
negative square root of 3 over 2, positive 1/2.
Positive 1/2. Yep. So there's your 30s. And the way you can remember which one goes where is when you draw a 30, 60, 90 triangle, you're always going to have one side that's short, and you're always going to have one side that's long. The long side is always the root 3 over 2. The short side is always the 1/2. So the long side is always root 3 over 2, because root 3 over 2 is a bigger number than 1/2. Root 3 over 2 is 0.86. 1/2 is 0.5. Okay. Yeah.
If it's a 60-degree angle, it's going to be completely different.
It's going to be a little different, but we really don't have to go through and do all the work again for a 60. We can just, and I'm not going to label all 4 of them because it's going to start to look really messy. But 60 would be right here. There's your 60 triangle. So if your 30 has that and that, your 60 has that and that. So I tried to color code it to give you a hint. Anybody think they know what the coordinates for 60 would be?
1/2 square root of 3 over 2.
1/2 square root 3 over 2. Yes. So 30 and 60 are the same triangle. It's just standing up rather than laying down on the long side. Okay. And knowing the 60, that allows you to do 60, 120, 240, and 300. Okay. So what ends up happening is there are 3 different angles in each quadrant you can do. You've got the 45, the 30, and the 60 in each, just like that. But there's a gap. You're missing the 15s, 15 and 75. Again, that's not something we talk about right now. And you also have these from yesterday. Those were the first 4. So now we have a total of 16 different points that we should be able to find the coordinate for. And then do trig. Okay, sine, cosine, tangent, whatever they want to know. All right. Let's try a few. Let's try the 6 trig functions of 45 degrees. What's the first thing that we have to know to find the trig functions? Yeah, gotta get the coordinate. What is the coordinate for 45? This is just something we now want to know.
Square root 2 over 2.
Square root 2 over 2, comma.
Square root 2 over 2.
Yep, the 45 is nice because both numbers are the same. Can't mix the order up. Okay. What's the sine of 45 degrees?
Square root of 2 over 2.
And which one did you pick, just so I know, because they're both the same?
The x.
You got lucky, because it's the y. Yeah. So the y is the sine. How about what's the cosine?
The x.
That is the x, which is root 2 over 2. And what about the tangent? What do you get when you divide y by x? 1. You're dividing 2 things that are the same. So tangent's 1. Since we're here, let's do the cotangent. What's the cotangent?
Isn't that also 1?
That's also 1. Okay. What's the first step to getting the cosecant? flip it. So you get 2 over root 2. But then when we fix it, you're going to multiply the top and the bottom by square root of 2.
2 square root 2 over 2.
That gives you 2 square root of 2 over 2. But what cancels out there?
2.
The 2's. So when you flip root 2 over 2, you just get root 2. How about the secant of 45?
Won't it be the same as the cosecant?
Yeah, it's the same because the sine and the cosine are the same. So you start to see the same answers repeated over and over because there's only 3 numbers you're working with to do the whole thing. Root 3 over 2, 1/2, and root 2 over 2. Any questions on finding the 6 trig functions at 45 degrees? Okay, let's try the 30. So with the 30, you've got to be careful because there's 2 numbers and they're different. One is a root 3 over 2, one is a half. Think of your picture. 30 degrees would look something like that. Which side is the long side? Is it the horizontal or the vertical? Right, with the 30, the horizontal is the longer side. And what did we say? Yeah. What did we say the length of the long side is?
1/2. No, wait.
Square root of 3 over 2.
Right, square root of 3 over 2. That is a bigger number than 1/2. It's 0.86, roughly. 0.87. So that's root 3 over 2. And what's the short side?
1/2.
So now I know my x is root 3 over 2, and my y is 1/2. Right. And that's very similar to the second, actually that's similar to the first problem we did today. Actually, is that the same question we did? The very first problem today?
No.
Now, what did we do for our first problem?
We did
The other way.
the 60.
We did the 1/2 root 3 over 2. So when we get to 60, we'll skip that one. So let's do this one then. All right, what's my sine?
1/2.
Yep, 1/2. What's my cosine?
Square root of 3 over 2.
Square root of 3 over 2. Now for the tangent, just imagine putting a fraction right there. And what would cancel out when you divide those?
The 2's.
2's, but you'd still be left with a 1 in the top
1.
and a root 3 in the bottom. 1 over root 3. But when we fix that, what do we get?
Root 3 over 3.
3 over 3. What's the cosecant going to be? 2. How about the secant?
That's
Final answer for secant.
2 over square root of 3, so that'd be 2 square root 3 over 3.
2 square root 3 over 3. Yep. And how about the cotangent?
That would be 3 square root 3 over 3, so it's just square root of 3.
Yeah, just square root of 3. And what I would do with that one is I would flip what's circled in blue. What's circled in black and blue are the same. But if you flip the one that's in blue, the root goes to the top and you're done right away. If you flip the black one, then the root goes back in the bottom and you got to fix it all over again. Okay, so that's the 30. And then the very first problem we did today was the 60. Okay, so I'm not going to go through it again, but this is 60 degrees. And what is the coordinate for 60?
1/2 for x, and then it's the square root of 3 over 2.
Yep. So you didn't know it at the time, but you already did all the trig with that coordinate. Now you know it's 60. Okay. Right, let's try just the 3 trig functions of 135. So let's think about 135. When we draw 135, it's somewhere between 90 and 180. Closer to 90? Closer to 180 or right in the middle?
Right.
Right. It ends at a 5 for the unit circle angles. It's right in the middle. So what triangle did we just draw? The 45-45 or the 30-60?
45,
45-45. What is the length of each side in the 45-45?
1.
I'm sorry, what is the length of each leg?
Root 2 over 2.
Each leg is root 2 over 2. But we have to take into account that we went left and then up. So what would be the coordinate for 135 degrees?
Negative square root 2 over 2. And then square root 2 over 2.
Yep. Okay, so now the sine of 135 would be
Square root of 2 over 2.
square root of 2 over 2. The cosine?
Negative square root of 2 over 2.
And the tangent?
That would be
-1. Yep. So that's why it's so important to figure out the coordinate. If you don't know the coordinate, you can't do any of them, right? Any questions on that one? And you can make a diagram with every coordinate on the same diagram, but then it starts to get a little messy unless you make it big enough so it's not all squished. So let's try the 6 trig functions of 7 pi over 6. What is it that we need to figure out about 7 pi over 6? We need the coordinate. Yep. What might make that angle a little bit easier if we're not comfortable working with it the way it is?
pi over 6. And
What's pi over? Yeah, how much is pi over 6?
30 degrees.
30 degrees times 7.
210 degrees.
210 degrees. That's the angle you're working with. Okay, we need to figure out the coordinate. So 210. Here's 270. Here's 180. Where's 210? Right in the middle? Closer to 180? Or closer to 270?
Closer to 180.
This one's closer to 180. When you draw a point that's closer to one than the other, is that the 45-45 or the 30-60?
30.
That's the 30-60. Long side? Short side. So for 210 degrees, what is the long side? What's the length of it?
Negative 1/2. Or negative.
Well, for now, just give me the length. Don't worry if it's negative yet. So the long side is 3 over 2. How about the short side? 1/2. Now, because we're in quadrant 3, when you write the coordinate using those lengths, both numbers should be negative. So negative root 3 over 2, negative 1/2. And what's the sign?
Negative 1/2.
Negative 1/2. Okay, cosine?
Negative root 3 over 2.
Negative root 3 over 2. And the tangent, when we divide them, what's going to cancel?
2.
2's and the negatives. So you have 1 over the square root of 3. And that's going to turn into
Square root of 3 over 3.
square root of 3 over 3. Yep. Okay. So any question on that one? All right. So when we get on the test, this would be 3 separate questions. Okay? Each one would be its own thing.
A, B, C.
Yeah. So like a question like that would be 6 questions on the test. Okay. So I'm only going to ask you to do 1 trig function per coordinate. But I am going to ask you for the coordinate, and then I'm going to ask you for one of the 6 things about it. So now, what do we do then if the angle is not a multiple of 30 or 45? Well, I told you if it's a multiple of 15, you eventually will know what to do. But for now, if it's not a multiple of 30 or 45, we're going to plug it in on the calculator. All right, so let's try 42 degrees. First thing we have to check is when we are typing it in on the calculator, the mode. Right now, my calculator is in radians. If I do this problem the way it is, I'm going to get it wrong. I need to change this mode to degrees. So if you press mode, and then go to the fourth option down, highlight degrees, hit enter, and now we're ready to do this problem. Okay, and all you really have to do is type in sine 42, cosine 42, tangent of 42. If you got those answers, then you are doing it right. If you didn't get any of those answers, then something is wrong. That's how you do the sine, the cosine, and the tangent of 42 degrees. Now, once we get the 3 on the left, what do we normally do with them to get the 3 on the right? Flip them. You have to do exactly the same thing on the calculator. To get the cosecant, you're going to take the sine and flip it, just like that. How are we going to get the secant? Yeah?
Do the inverse of the cosine?
Careful, not inverse. Inverse is a very special word in trig. We are going to talk about inverse cosine, but that's just not what we're going to do here. So the word that we're going to use is the reciprocal. Yes. So 1 divided by the cosine of 42. There's your secant. And how are you going to find your cotangent?
The reciprocal of the tangent?
Reciprocal of the tangent. There is no other button on the calculator to automatically do that for you. You might think you see this button here that has this -1 thing. Don't use that. That's not going to help. All right. So there's your sine, cosine, tangent, secant, cosecant, and cotangent. All right. Did all those. What about this one? What would I have to do on my calculator to type this one in?
Change to radians.
Right. How do you know it's radians?
There's no degree sign.
There's no degree sign. I'm not going to tell you on the test. Make sure you look at the angle and see if there's a degree sign. You just have to look at it and say there's no degree sign. That means you need to go back to radians. If your calculator is in degrees, it will not come out right. So the sine of 10 and the cosine of 10. And those are your two answers. Any question on that one? The calculator is pretty straightforward. The most thing that I usually see people get wrong is they forget how to do the secant, cosecant, and cotangent. Okay, so yeah, there's a lot of things I'm skipping. Okay, so we're good with that. So these trig functions that we've been flipping one to get the other, those are called reciprocal identities. I mean, I've already been trying to get you guys to use that word anyway, reciprocal. So the idea is the connection between sine and cosecant is if you take the sine and flip it, you get the cosecant. If you take the cosecant and flip it, you get the sine. So if you flip it, it just keeps going back and forth. Flipping the cosine gives you secant. Flipping the secant gives you the cosine. Flipping the tangent gives you the cotangent. Flipping the cotangent gives you the tangent. So those are called reciprocal identities. I think we're not doing that or that yet. So this is the last. Okay, so those are reciprocal identities. Okay, and then just a couple facts about sine and cosine. When you draw, I don't think we've looked at the picture of sine and cosine yet. We will a lot later on. That's the picture of sine. As that's drawing, would you ever need to lift your pencil to draw that? No. So then the domain is all real numbers. It's a wave that goes on forever. And cosine is almost exactly the same picture. It's a horizontal shift of sine. Okay? So they're just horizontal shifts of each other. So sine and cosine are almost the same thing. Notice that when you draw them, the highest they go is 1, and the lowest they go is -1. That's why I put the range 1 and -1. Now, if you're wondering, why didn't I write down like properties for tangent and all the other ones? They're a lot different. So tangent looks extremely different. It has vertical asymptotes, and it is not connected. You have to pick your pencil up each time you draw a new section. So same thing with secant, cosecant, and cotangent. None of those other 4 are nice waves. Sine and cosine are the only 2. Okay. Any questions on that? All right. So we're not getting into that a lot right now, but that'll be something we do a lot more later on. All right. I think that's it. Okay, so let me just double check. So 13 through 17, that's just finding the sine and the cosine. You do not have to do all 6. Only asking for sine and cosine on those ones. 21 to 25, it's having you do the other ones that aren't sine and cosine. 29 to 32, that's all on the calculator. 37 to 40, that's all on the calculator. Let's do 45. 45, they give you an angle bigger than 360. But I think I went over one today. What do you do when it's bigger than 360? Right. Just subtract 360 from it. They say use the periodic property. It just sounds confusing the way they say it. Basically, just do it like you do any other problem. Okay, so 45, and then 50. That's good. Okay, so I did change a few things, and it's very different than the video from last year. So make sure if you do look at the video, look at the one on YouTube. I will put a list of topics for the test, and I will be after school today for extra help if anybody needs to come by.